Hey developers, welcome back to Code Connect. So in today's video, we will be diving deep into Qwen3-Coder. So Alibaba has recently launched its large language model known as Qwen3-Coder. So in today's video, we will be seeing its architecture, its performance with other models in the market, and we will be seeing its SWE benchmark test. So let's go ahead. So this model is offering us 480 billion parameters, out of which 35 billion active parameters. So what this statement means? So whenever you ask model a question, so this statement means that for each question only 35 billion parameters will be active for that question. Not all 480 billion parameters will be activated at that time. So this is a very intelligent approach, because if we activate all the 480 billion parameters, it will increase our cost, it will increase computation. So it only active 35 billion most relevant parameters for that particular query. So the model identifies like which parameters need to be activated for that query, for that input, and for that we are having experts. So there are 160 experts, out of which only 8 experts are activated per input, and these 8 experts are having 35 billion parameters. So this is the approach of mixture of expert model. In this model there are multiple experts, and each expert has some specialty, like there is a physics expert, there is a math expert, there is a chemistry expert. Also if you ask math query, then the math expert will be activated. It's just like that. The model has 62 layers. So these are the transformer layers, and each layer do some tasks like feed forward, normalization, and something like so like the data goes through each layer. It's like all these layers are stacked on one another. So in order to move data, we need to go from 1 to 62 layers, and each layer is updating the data, it's normalizing the data, it's serializing the data. So yeah. Now if we see one of the best thing this model is having is the token context. You will be like amazed by this. Like this model is having 2,56,000 token. This means that entire GitHub repository you can give to this model, and the model will have that amount of context. And they are also saying that we can extend this to 1 million using Yarn. So if you don't know what is Yarn, Yarn is basically a tool, is a model which help us to increase the context of the model without retraining the model. If you see the attention part, they are having grouped query attention instead of normal attention, in which they are giving 96 heads for query and 8 heads for key and value pairs. So attention basically help in memory optimizations, and without much compute, it's giving the same performance. So like they help us to reduce the computations and while keeping the performance intact. So this is the part of performance. So this attention giving the model the efficiency in cost, in memory, and also the more efforts towards the question asked. Now let's move ahead and let's see this table, and this table is being provided by the Qwen itself. So in this, like they have tested on multiple benchmarks. If you see, like there is a SWE benchmarks, there is some web arena, Mind2Web, and they have tested on agentic coding, agentic browser use, agentic tool use, and they have compared with these 5 models. This is Qwen3-Coder, this is the same model itself. There is Qwen2, DeepSeek V3, Claude Sonnet 4, OpenAI GPT-4 4.1, and since they are like focusing on like coding, like their model is focused on agentic coding related tasks. So and now in current world, the model which is heavily focused on coding is the Claude Sonnet 4 model. And if you compare both of these performance, they are comparable. In some it's ahead, in some it is low, but if you see on SWE benchmark, it's quite comparable with Claude Sonnet 4. And the biggest advantage this model is having is the context window. Claude does not have that amount of context. Let's see the Qwen usage. So if you are able to see it, you can zoom it if you having trouble seeing this. So if you see the Qwen3-Coder usage, so we can use this for chat completion, like standard Q&A, code generation, debugging helps, all these things, like which normal LLM also able to do it. Like with ChatGPT we are also able to do this. You can use fill in the middle. So in fill in the middle, what it means like you given some code in which some part is removed and you wanted to complete that code, so you can give it to the LLM, and here like LLM will be easily able to do it. So the code insertion ho gaya, like template completion, gap filling, all these things. Like function calling, which is like agentic part, in which the agent calls the tools based on the request, and tool integration, API calls, function executions. Agentic coding, yeah. So multi-step planning means like first planning, then execution part, and then debugging part. Iterations, multiple iterations are happening on this based on the result of the code. Environment interactions, iterative problem solvings, all these things we can use Qwen for. Similarly, like just like the Claude, we are using Claude for if you if currently when you are going to ChatGPT for the same question and going to the Claude for the same question, you are getting much better result from Claude. So in the same way, you can now go to Qwen as well, but since the Claude was having lesser context size, it will be having more context size, so you will be able to give more context to the model, and due to which the response will be much better. Even not better than Claude, but it's quite comparable with Claude. So yeah, next move ahead. These things we have already discussed. You can read this, pause the video and you can read this thing. And this is now the main part we need to focus is the training part. How this model is being trained and what its capabilities we have already seen in the previous slide. So here we are focusing on this part. So on the training part, this model is trained on 7.5 trillion tokens, and they are claiming that 70% of the token was code related, and they have trained on 358 programming languages, almost every programming language. So it's being trained on. There is synthetic data enhancement. So what does this mean? Synthetic data enhancement means like there is some noise in the data, there is some dirty data, so they are using Qwen 2.5 for cleaning the data, and they are using it. So this is the part. Next, move ahead. So in the training pipeline, they have done training in two phases. Like there is a code reinforcement learning and there is a agent reinforcement learning. So in the code reinforcement learning, what they have done, they have given Qwen some task of writing the code. Qwen has written the code. So Qwen is internally checking the code result with the test cases, and based on that test cases, it is giving reward to the LLM, and based on that reward, LLM is learning itself. So if you see, like if the code output and there are test cases, if the output is correct, then it is a positive sign. If it is negative, then it is a negative sign. The negative reward is given to the LLM, and LLM work on that. If it is a partially correct, then it is a scaled reward. In that case, LLM do something reiterate it. So there are multiple iterations being going on. There is agent reinforcement learning. So in that they have used agentic part. So what they have done, they have created 20,000 parallel environments, and in each environment, they have given some software engineering problem which the LLM is doing, and those problems required multiple tasks, like planning, iterations, debugging, executions. All these things were happening in that. You can go through it. So yeah, there is a pre-training process and there is a post-training process. So in the pre-training, you see there is a data scaling, which 7.5 trillion tokens, out of which 70% are code related, and 358 programming languages. And they have context scaling. So like as we seen that it is having 256,000 context token window, and so there is a repository scale understanding, dynamic data processing, like pull requests, all these things. Dynamic means like we are pulling the data. So in the pull request, the data is like we are getting from the pull request URL. There is synthetic data quality enhancement. So Qwen 2.5 coder, data cleaning, noise reduction, and rewriting. So this thing we have discussed. There is in the post training, after training, pre-training, there is a code reinforcement learning, and there is a agent reinforcement learning, which is also called long horizon reinforcement learning. So here in the code reinforcement learning, what they have done, they have execution driven learning. They are having a real world coding task and test case scaling, success rate optimizations. And in agentic, they have multi-turn interactions, tool usage testing, environmental feedbacks, and 20,000 parallel executions, environments executions. So this is the graph which I am talking in the starting. They have tested on multiple cases like code generation, software development, competitive coding, data analysis, multi-language programming, code editing, SQL programming, instruction follows. And in each of these, if you see, like the graph is going upward. In some board there is a plateau here, and but it's mostly going upward. So in the Medium article, I have deeply explained this, so you can go through that article as well. So now let's see the SWE-Bench software engineering benchmark test. So if you see in this, they have included in this chart, like there is a Devstral, Qwen, 235 billion parameter model, Claude Sonnet, Kimi, GPT-4.1, DeepSeek. And if you see, like in this graph, Qwen is here, and Qwen is here and Claude is here. So both of them are comparable with each other. You can pause the video and read the use cases of this model. Till then, let's go to the Medium article and see like what I have explained in this. So I have written here what is Qwen3-Coder, its architecture, its core features. So here I have explained like the 480 billion parameter. What does it mean by this 480 billion parameter? What is mixture of experts? This I have explained here. So if you see here, like only 8 experts out of 160 are activated for each input, smartly selecting relevant subnetworks. This allows huge models to be used efficiently with better latency and cost. You can read this, the 62 transformer layers. Each layer does the usual transformer magic, self-attention, feed-forward normalizations. You can read this. This is grouped query attention. So it's optimized. So there is also a multi-head attention as well, that reduces computation while keeping performance. But with multi-head attentions, like we are giving only like the same number of heads for each of these things. But here, like we are giving 96 heads for query and 8 heads for key value. So if you see, like this is more powerful and memory efficient attention. Context size you can see from here. Yarn, you see like it uses rotary positional embeddings for interpolation. You can read this about in the from the net, from the GPT as well. Yarn, so method extend context length without retraining the model. Agentic capabilities, like while giving answer, it can use tools, it can use browser, can reason across multiple steps, can fill missing code, supports tool calling APIs. Here I have explained about the training pipelines. The code reinforcement learning we have already seen. So here the process is there. The model receives a coding task, model writes code solution, code runs in real environment, result checked against test cases, reward assignment, like if correct output, how positive reward, high positive reward, wrong output, negative reward, partial scale reward. So a model weights updated based on reward. So you see, like after each execution, like model weights are updated. So it's learning while executing. There is a agent reinforcement learning. So in this there are multiple step processes, planning, break down complex task. So the task which is given, it break down in this task, then choose appropriate APIs, libraries, write code incrementally, then run and validate the code, fix issues based on feedback which we have given here, and refine solution multiple times, so like iterations. So why parallel environment matter? So massive data generation, 200x more learning experience. So if there was no parallel environment, we are only running in the one environment, but like there is a massive data generation, like 200x more learning experiences, diverse scenarios. Each environment has different challenges. Real-time learning model learns from simultaneous experiences. Scalable training can handle complex long horizon tasks. So this is a chart which we have seen in the slides. You can go through these like inferences of these, like what does each of these means. So if we see the training inside, common patterns observed, like initial rapid improvement. All tasks show quick gains early in training. Plateaus. Most tasks hit performance plateaus, indicating optimization challenges. Variability. Some volatility normal in reinforcement learning training due to exploration versus exploitation. So if you see, like most tasks hit performance plateaus. So if you see, like there is a plateau here. Because indicating optimization challenges, there is some challenge in optimization. Now let's see the practical usage examples. So if you see the example one, like basic chat completion with transformer. So here we are asking the model to write a quick start algorithm, and we have used transformer here, and model is this one, Qwen3-Coder 480 billion 835 instruct. We have created a model here. We have also get the tokenizer from the model name. We have created a prompt. We have created message in which we are having a role, user, and content prompt. We are asking tokenizer to create a token to create a text, and we are giving this text. We are generating the model input, and finally we are giving the model the input and the token size. There is another way of using this is the fill in the middle. In this, like we are giving some input in which we are removing some code and asking the model to act as a code completion assistant and give the response. Agentic tool calling. So here we have created a tool. We are using OpenAI, and OpenAI key and base URL we are passing here. We are creating a message like square the number. So like this tool basically is for like squaring the number, and in this we are adding the model and message and tools. SWE benchmark test we have already seen that you can read from here. Okay, like on real world software engineering tasks for actual GitHub repositories. This thing. You can also like if you want to like run this model in your local, or you want to integrate this model, you can go through all these things. So if you wanted to run in local, you need to install this Qwen code using the npm command, and then you need to set these keys like OpenAI key, OpenAI model, OpenAI base key. So here we are using Qwen3-Coder plus, and simply you can write this Qwen. The model will be running in your local. You can also integrate this model to your Claude Code. So you can install Anthropic AI Claude Code, and you can set these keys as this one. And if you wanted to use in Cursor or VS Code, you can install the client extension. You can configure it to use as a OpenAI compatible. You can use this base URL and model as Qwen Code 3+. So through this you can use this, and these are the use cases. So yeah, you can go through all these things. So it's a quite interesting model, and it's a like big model, and which basically come from China, again. So like we from China we get DeepSeek. There are other models also coming from China, and so like the Chinese model are quite cost efficient. Like they basically give the same thing which we are getting from other companies in more price. We are getting from those in lesser prices. So similarly with the DeepSeek, and they have made this open source. So you see that. So this is like in future, like we will be covering all the things which are coming in AI. So subscribe our channel for getting more and keep better with us. So like we are also learning, and with each video we will be learning. So yeah, thanks for watching this video. Let's meet in next video.